We're starting section 1.2, which is types of data, where the focus is determining source, selection, and criteria of the data to be collected. Okay, more vocabulary. And more math. Oops. We're expanding what we're doing all the time. Here we go. We have two types of data, parameter and statistic. Parameter is a numeric measurement describing some characteristic of a population. All right, so this is the focus. A population study. And that's the key part of a population. Parameter is what are the extents of what we're going to cover within that population. A statistic is a numeric measurement describing some characteristics of the sample. The focus on a sample size that reflects population study. Again, we're looking at the numeric measurements that we're going to be using in order to determine an analysis and a conclusion. The alliteration of population parameter and statistic sample statistic helps us remember the meaning of these terms. Parameter relates to population, statistic relates to sample. So we're going to do an example. Determine whether the underlined number is a statistic or a parameter. All right, it is not underlined, so we're going to talk about that part right there. All right, a sample of seniors is selected and it is found that 55% own a television. Choose the correct statement below. Statistic, because the value is a numerical measurement describing a characteristic of a population. And we know that's not true because it said sample. All right, so we ruled out the first one. Statistic, because the value is a numeric measurement describing a characteristic of a sample. And this is our answer. But let's look at the fact that it's not a parameter. It's definitely not a parameter because it is a sample. Okay, so we're getting concise information regarding the difference between sample statistic and population, parameter population. All right. So here we have another type of distinction, and that's quantitative, consists of a number of numbers representing counts. This is the key words, counts of a measurement. Categorical is qualitative, consists of names or labels of what we're studying. All right, so here we have an example. It says determine whether the data describes is qualitative or quantitative. The ages of a random sample uh, of women. All right, so this one is it quantitative? Well, yes, it's a count of women, count of ages. It's a count of ages. So it is quantitative. The data are quantitative because they don't measure or count anything. Well, that's wrong. They do. The whole process is that. Um, uh, the the data are qualitative. Well, no, they're not counts. It is not. Now remember what the other one is. Qualitative consists of names or labels. Nope, no names or labels, so that's not that one. The data are quantitative because they consist of counts of measurements, and the measurements are ages. So it's this one. So we've learned that we have uh, parameter, population, uh, sample statistics, for some reason it just escaped me. And then we're going to have, and this is pretty close, quantitative, qualitative. Countable and qualitative is categories. All right. So now we're going to add something else now. Discrete and continuous. Discrete and continuous. As we continue on in our study, discrete means that they are finite and countable. Finite means specific number. Countable means 1, 2, 3. Okay. Countable, specific, finite. Continuous, many possible quantitative values. Continuous means infinite possibilities. So we're talking here, um, uh, it is one of those cases like we have weight. Weight is continuous because there's parts of a pound, or height, parts of height is parts of feet, inches, and so on. We can get very specific as to what we're measuring in this case. So let's look at the distinctions with examples to make sure we understand. Tell whether it is discrete or continuous. Okay. Number of countries in the world in different years. This is countable. Therefore, it is a definite answer, discrete. Duration of a movie in minutes. Well, that's infinite. Duration. And so therefore, it is continuous. The number of teachers in a school year. Well, that's discrete. Can't have a piece of a teacher because it's countable. Times and minutes that callers are put on hold by a customer service call center. And of course, that is continuous. Right. So we can see how we've constructed continuously in, in this study the various parts of statistics, again, focusing on vocabulary. Okay, so let's talk about something that is different in approach and very important in understanding. Very important in understanding. So what we have here is levels of measurement, levels of this continual measurement. And in this case, and I'm going to make it larger so you don't have any trouble reading that, we have a ratio. A ratio usually means a fraction. Well, fractions or decimals, right? So in this, there is a natural zero. And then there are points and ratios that make sense. Height, lengths, distances, volumes, all vary. And so they are a ratio. They don't have a distinct direction. They are independent of each other. The interval. This one was hard for me. It's the differences are meaningful, but there is no natural zero, in this for starting point, and ratios are meaningless. Intervals like body temperatures in degrees Fahrenheit or Celsius. Now, the reason for that, because you're talking about a sequential order, as well as groupings. Sometimes done to organize all of these interval scenarios. Ordinal, I like that one. That one is just what it says, like in order. First, second, third type idea. Well, the data is arranged in order, but differences either can't be found or are meaningless. Ranks of colleges in the U.S. World Report. Okay, so they're meaningless because they vary as each time you take the data. Ordinal. Nominal, another one that's easy, and this is category. This doesn't mean that there's order of any kind. It doesn't mean there's fractions. It doesn't mean anything. It's a count, and they are by eye color, gender. Um, it is vehicle types. Those kind of things are nominal. Now, this one you need a chart. So keep this little particular chart at hand so you'll have no issues, because it's kind of a little bit convoluted in some cases to me. Okay, types of restaurants. Well, those are by name. Fast food, organic, seafood, etc. They're by names, therefore it's nominal. Blood levels, low, medium, high. This is in order. So therefore it is ordinal. Ages of children: 5, 6, 7, 8, and 9. Now this one's a hard one. It is a ratio. And that's because of the various ages that children have. Because you can have 5.5, you can have 5 3/4, those type of categories. And so therefore it is a ratio. That one's hard. Stress scores where the mean is 0, which that remember the 0 is a ratio, or now that's about it, isn't it? 0, no natural 0. This one ordinal can have a 0. So what is this one? Oh, did I cover interval? Yeah, the interval. Oh, interval does have a 0. All right, because it's temperature. So the scores where the mean is 0 and increments of measurements are equal. So that means they're groupings. Excuse me. So this is an interval because it's a grouping in order. Groupings in order. All right. So we're moving right along. So now let's talk about the level, identifying these measurement levels, and explain what's wrong with the given calculation. In a survey, the favorite foods of respondents are identified as 10 for Italian, and I misspelled it, 20 for Mexican food, 30 for Chinese, 40 for anything else. The average, the mean, is calculated for 557 respondents, and the result is 22 and 3/10. Well, okay. The data is nominal. We know that. And it's bad because an average has no importance. To figure out restaurants. I mean, 22.2. Well, does that mean it's Mexican and Chinese? So you can't say that. Okay. So let's see what the choices are. The true average mean is 19.5. Meaningless. Such data are not counts or measures of anything. So the average mean needs to be computed in a different way. You can't compute the mean. Such data are not counts or measures of anything, so it makes no sense to compute their average. Yes, there is nothing wrong. Oh, well, that's because we said, I mean, what does the average mean? Nothing. What you're looking for is which one is uh, most visited. All right, so here we have one that says, do you know what the meanings are? Which of the following is not a level of measurement? All right, so nominal is a name. So that's not a measurement. Quantitative, um, quantitative, yes, counts. Therefore, this is it. Ordinal is in a specific order. So no, not countable. And a ratio. All right, now remember what the ratio said. Okay, because we have to consider everything. A ratio, there is a natural zero, and they make sense, but they are not countable. So it's not really a measurement, it is more of a grouping. So the only one is the quantitative, is countable. Which of the following consist of discrete data, and which of the consists is categorical? All right. All right. So tree heights, it's not discrete. It is infinite in measure. Hair color. Oh, now that's interesting, right? Hair color is categorical. And number of suitcases. Now that's discrete, countable. Amount of rainfall, infinite in measurement. There we go. Getting a handle on this vocabulary. You're doing great. Um, and that takes care of this section. Now you can do the homework. Thank you for listening.